In this video, we will learn about output offset voltage V0, II0 caused by the input offset current II0 in an inverting or non-inverting amplifier. Output offset voltage V0 due to input offset current II0 caused by the input offset current II0 in an inverting or non-inverting amplifier. Non-inverting First of all, draw the inverting amplifier configuration. This one inverting amplifier configuration, minus, plus. This one is RON. IB1. VE. This one is R1. RF. IB2 plus VCC and minus VE. RL. Output voltage V0. This is the inverting amplifier configuration. This ROM is the offset minimizing resistor. Offset minimizing resistor. Input bias current effect is eliminated by using this ROM. Input inverting amplifier with offset minimizing resistor ROM is the R1 parallel to R. Under present conditions, Vin equal to 0. This circuit diagram is transferred into minus plus RON, that is equal to R1 parallel to RF. R1, Vin is 0, that means connected to ground. This one is the IP2, V1 voltage here, V2 voltage, V0, RF, this one is RL. IB1, current flow through the ROM resistance. This is the inverting amplifier. In case of non-inverting amplifier configuration, this one is non-inverting, minus plus. Here Vin is applied to non-inverting terminal of the top-amp. This one is Vin is applied to non-inverting terminal, that is in series with ROM. And this one is R. R1, R2, RL, V0, Suppose Vin is equal to 0. This is a non-inverting amplifier. Non-inverting amplifier with offset minimizing resistor. Minimizing resistor RVM. Here Vin equal to 0. This diagram is transformed into this one is R1, this one is IB1, IB2, this is IB2 current. IB2, IB1, this one is R1, V0, RF. This voltage is V1 and this voltage is V2. This voltage is V1, this voltage is V2. This one is RF. R2 or RF here RF. This is the inverting case, inverting op amp. Here RVM is there, RVM is connected to an inverting terminal. Vin is 0. Vin is equal to 0. The circuit diagram is like this. This is the inverting op amp. Here in non-inverting op amp, this is a non-inverting op amp. Both the circuit diagrams are similar, inverting op amp and non-inverting op amp. When Vin is equal to 0, RVM is the offset minimizing resistance due to input bias current. Here we use only one circuit. We use one circuit. One is plus, minus plus, ROM. This one is IB1, V2, V1, R1, RF, V0, IA0. This one is IB1. Find out, suppose the use of ROM in series with non-inverting terminal reduces the output offset voltage due to IB, due to input offset current. The use of, this is a very important point, the use of ROM in series with the use of ROM in series with non-inverting terminal reduces the output offset voltage V0 due to input bias current. V0 IB means due to IB, input bias current. The value of ROM, important point, the value of ROM was derived based on the assumption that the input bias currents IB1 and IB2 are equal. Second important point is that the value of ROM was derived based on assumption that the input bias currents are equal. The input bias currents IB1 and IB2 are equal. In practice, these currents are not equal because of the internal imbalances in the op-amp circuits. In practice, these currents are not equal. These currents are not equal because of the internal imbalances in the op-amp circuitry. That is, go for another current. Instead of input bias current, we use input offset current. The input offset current is used as an indicator of the degree of mismatch between these two currents. The input, the IA0 is the input offset current. The input offset current is used as an indicator of the degree of mismatching between these two currents. Therefore, IIO is equal to input offset current is the algebraic difference between the two input bias currents. IB1 minus IB2. IB1 minus IB2. With the help of this circuit, I have to determine the V0, II0. IB1 and IB1 here IB1, here IB2. These two currents are not equal sometimes. Due to that input offset current II0, algebraic difference between these two bias currents IB1 minus IB2. Here two voltages are there, V1 and V2. Applying superposition theorem and find out the V0, II0 due to IB1 and IB2. Case 1, V1 is equal to 0, V2 is acting as V1 is equal to 0 means the drop across ROM is 0, IB1 and ROM is equal to 0. Therefore, V2 is also 0. Whenever V2 is 0, here V2 is also 0. Here the current flow through R1 is also 0 because of R1 is connected between two grounds. First, initially V1 is equal to 0. In case 1, apply superposition theorem. V1 is equal to 0. According to virtual ground concept, VAD, one more assumption is VAD, difference voltage is also 0. That means V1 minus V2 is equal to 0. Therefore, V1 is equal to V2 is equal to 0. V2 is equal to 0. R1 is the resistance connected between two grounds. Therefore, there is no current flow through R1. IB2 current direction is like that. Here, this node, this one is IF current. These two currents are away from the node. Therefore, IB2 plus IF is equal to 0. IB2 is equal to minus IF. IF is equal to V2 minus V2 minus IF is equal to V2 minus V0 due to IB2 by R by R. Therefore, here V2 equal to 0. V2 is equal to 0. Therefore, IB2 is equal to minus output offset voltage due to bias current IB2, input bias current IB2 by RF. Therefore, V0 IB2, output offset voltage due to input bias current IB2 is equal to minus RF into IB2, minus RF into IB2 when V1 is 0, V1 is equal to 0. This is the case 1. V1 is equal to 0, V2 is also 0, V2 is also 0. According to nodal, and the resistance R1 is connected between two grounds. Therefore, IB2 plus IF is equal to 0. Therefore, IB2 is equal to minus IF. IF means V2 minus V0 IB2 by RF. That is equal to V2 equal to 0. V2 is equal to 0. Therefore, minus of 0 minus V0 output offset voltage due to input bias current RF, that is IB2. Therefore, output offset voltage due to bias current IB2 is IB2 into RF. Here minus sign is used here because that voltage is negative. That voltage is negative. This is the non-inverting amplifier case. Here minus sign, here plus. Next one, in case 2, this is the case 1. In case 2, V1, in case 2, V2 is equal to 0, but V1 is equal to ROM into IB1. The assumption is VID is equal to 0, V1 minus V2 is equal to 0. One more assumption is here. In case 2, due to V1 is equal to ROM into IB1. But VID is equal to 0. VID is equal to 0 means V1 minus V2 is equal to 0. Therefore, V1 is equal to V2. V1 is equal to V2 is equal to ROM into IB1. ROM into IB1. This is the circuit diagram. Minus plus, here V1, here V2, V0 due to IB1. This one is RF, ROM. This one is IB1. This one is IB2. Here, due to this one, due to V1 is equal to V2 is equal to ROM into IB1, V2 is equal to ROM into IB1. Apply nodal analysis at point 2 here. V2 into Apply nodal analysis. This one is R1, 1 by R1 plus 1 by ROM, 1 by ROM, 1 by R1 plus 1 by ROM. These two are connected, minus V0 IB1 by RF. Here I have done one mistake here, not ROM here. One by RF. For this node, RF and R1 are connected. That is the reason that voltage into consider admittances 1 by R1 plus 1 by RF minus V0 IB1 by RF is equal to 0. Minus 0 by R1 is neglected. Therefore, V0 IB1 is equal to RF into V2 into RF plus R1 by R1 RF. RF is cancelled. We know that V2 is equal to ROM into IB1 RF plus R1 by R1. That is equal to ROM. ROM is nothing but parallel combination of R1 and RF. That is ROM is equal to R1 RF by R1 plus RF into IB1 R1 plus RF by R1 plus RF cancel. This R1 is cancelled. Therefore, IB1 into RF. V0 IB1. This is the equation number 2. This is the equation number 1. V0 IB2 is equal to minus IB2 RF. V0 IB2 is equal to minus RF into IB2. Minus RF into IB2. Therefore, some total voltage, output offset voltage due to input offset current is equal to V0 IB1 plus V0 IB2. V0 IB1 is IB1 RF, IB1 RF plus minus, here not plus, minus RF IB2. RF is the common term in both the cases. That is equal to RF into IB1 minus IB2. IB1 minus IB2 is the IIO. Therefore, output offset voltage due to input offset current is equal to feedback resistance RF into input offset current IIO. That is the derivation. Without ROM and with ROM, we consider without ROM and with ROM. The value of input offset current IIO, the output offset voltage V0 IIO depends on the feedback resistance RF. This is the derivation. The output offset voltage due to input offset current. That input offset current is due to IIO is due to a mismatch of these two transistors. Input two transistors bias currents IB1 and IB2. ROM is the resistance connected in series with the non-inverting terminal of the op amp. It is used to eliminate the output offset voltage due to input bias current. Output offset voltage due to